In this video, we're going to see how to calculate a confidence interval for a single proportion using the BRFSS dataset. So to start out here in R, I have the Module 11 script. So you want to make sure that you download this script from Canvas, and then also you've got either the Kentucky dataset available to follow along with me, or if you want to work with your own dataset to follow along. So in this video, like I said, we're going to create confidence intervals for a single proportion. So for example, if we were looking at mammograms, for example, we might be interested in finding out in the population of interest what are some plausible or reasonable values for the percentage of all women in our population of interest that are receiving a mammogram. And confidence intervals can help us do that. And what they do is they take the information contained within the sample and they use that information to help give a range of reasonable values of what's happening in the population. So we're going to look at several different confidence intervals here, and as we look at those, we'll talk about the interpretation and what that is telling us. So to start out with here, I'm going to set my working directory, and that tells R where on my computer the data set is located. We're going to read in the data and then just check the data set quickly. So we've been doing this for several different modules now. So to start out with, I have the line of code here to set my working directory. You can copy this line of code over from one of the previous modules, or if you'll recall, you can always click on Files, these three horizontal dots to go to the directory, navigate to where the file is located on your computer, and then set the working directory by clicking More. Right, so my working directory has been set, and now I'm going to read in the Kentucky data set. Remember, it's always a good idea just to view the data set to make sure everything looks as expected. Up here I can see I've got 2,869 observations of 18 variables, which is what I expect. And if I run the view line, the data set will also come up so I can kind of scroll through and make sure that everything looks as I would expect it to. Right, now that we've read in the data set, we're going to go ahead and create some confidence intervals. We are going to need the tidyverse, so go ahead and run library tidyverse. Just as a reminder, if you're working on a computer that's different than the computer that you typically work on, you'll also want to go up to Tools, Install Packages, and install tidyverse. But if this is a computer you've worked on previously, you won't need to do that step. Now the next thing we're going to do is we're going to see how to create some different confidence intervals. I'm going to work with the pneumonia vaccine, which we've seen in some previous videos. And if you'll recall, one of the things that we like to do with these variables is to give some meaningful labels. So if we were to go and we would look at the code book, we would see that the pneumonia variable takes 3 different values in the code book, 1, 2, and 9, and these correspond to a yes, no, and unknown. So we're going to use this line of code here to relabel those values for the pneumonia variable. And again, we've seen this line of code in past videos, but just kind of review how this code is set up. What we're doing is we're calling the Kentucky dataset, which is the dataset I'm working with, $, and then I'm creating a new pneumonia variable. And so I'm going to call this x underscore pneumon3 underscore new. I'm going to set this equal to, and I'm going to use the with function here. And what the with function does is it starts with my original data set, which is the Kentucky data set. Here I'm going to enter the name of the variable in the original data set. And then we change the levels and the labels. So in your data set, when you're working with whichever variable you're working with, things you'll need to change are, you'll want to change the name of the data set in both places to be the name of the data set you're working with. This is the name of the variable in the original data set you're working with. As a reminder, the reason that we put an X out front is because R will not let variable names start with an underscore. So any variable name that starts with an underscore in the code book needs to have a capital X out front. I'm going to give this variable a new name. So this is the new one that we're creating. I typically just use the old name underscore new to do this. And then for whatever variable you're working with, you'll want to give the numeric numbers. These will go in between these two parentheses, separated by a comma. And then in the labels, you'll give the words that those numbers correspond to, with each of these in quotations, and again, separated by a comma. So if we run this line of code, notice we could go back and review our Kentucky data set by running this line, or I could double click here to bring up the data set. And if we scroll all the way to the end, we do see our new pneumonia variable. And so notice, for example, if we look at the original pneumonia variable, the first observation had a value of 2, and notice the 2 has been changed to a no. The second person had an unavailable or an NA, so that just stays NA. But if we come down here, we can see this person had a 1, and that 1 has been changed to a yes. So just doing some quick visual checks, everything looks okay. Now, the next thing we're going to do is we're going to create a frequency table, and that frequency table is going to also have the confidence interval with it. And so you've actually seen majority of this code before when we created frequency tables, but I have added a couple extra things to it that will compute the confidence intervals for us. So here, this piece that I have highlighted, this is the piece of code that actually creates the frequency table. So notice I have not highlighted the table 1 in the arrow. I've just started with subset and gone to the end. So if we run this, notice we get a frequency table down here. The difference from what we saw previously is previously we just saw the first 2 columns. The first column gives me the frequency. So for example, in this particular sample, we had 611 people say they had received the pneumonia vaccine, which correspond to a proportion of about 0.64 or about 64%. We had 235 people say no in the sample, and approximately 25% of the sample said no. The new 2 columns that have been added, these are the upper and the lower bound for the confidence intervals. So for example, if we focus on the yeses here, if we remember how a confidence interval is constructed, the idea of a confidence interval is that we take the information from our sample, in this case about 64%, and a confidence interval builds an interval around that value from the sample and gives a range of reasonable values for what's happening in the population. Because notice, the data that we have here only comes from a sample. So this confidence interval tells us that about, if we round this to 61% up to 67%. So this tells us in the sample, somewhere between 61 to about 67% of people in our population of interest have received the pneumonia vaccine. And the confidence intervals we're creating here are 95% confident. So more specifically, we're saying that we're 95% confident that the proportion of people in our population of interest, or the percentage of people in our population of interest that have received the pneumonia vaccine, is about between 61% to 67%. And notice that in the sample, again, we found about 64%. 64% falls right in the middle of 61 to 67%. So the big idea with these confidence intervals is they give us a way to take the information that's contained in the sample to give us a range of reasonable values of what's happening in the population. So looking here, what I've done is we've created the table, and notice when I just highlighted these pieces of code, it produced the table down here. Well, we're actually going to need this table to add confidence intervals onto our plots. So what I'm going to do is I'm going to save this table as what I'm going to call table 1. And I can do that by setting table 1 equal to, there we go, equal to that table we just created. So remember in R, when you have this left arrow, that's the same thing as an equal sign. So now if I highlight all of this code and I run it, notice nothing new is produced down below, but we do have a table 1 that is saved up here. And so if I now call table 1 will appear down below. And now I can use this table 1 to create a new bar chart where that bar chart has the confidence intervals on it. So let's see how to do that. We're going to use ggplot, and this is going to be somewhat similar to what we've seen before. So let's run this and see what it produces. So here's our new plot, and we're looking at the different percentages of whether or not people have received the pneumonia vaccine. So we've seen this bar plot before. We've got our relative frequencies here on the left, and along the bottom we have they received the vaccine, they did not, or that their status was unknown. The new piece here is we now also have confidence intervals over top of each of these bars. So what these do for us is we can look at the bar chart, and again, we can see in our sample, we had about 64% of people receive the pneumonia vaccine in the sample. But what we really want to learn about is what is happening in the population. So these confidence intervals that we place over top the bar, this allows the reader of a report or the reader of this bar chart to see, oh, okay, so this is what's happening in the sample, but these bars help me give an idea of a reasonable value of what might actually be happening in the population. And we recognize that anytime we have sample information, what's actually happening in the population is probably slightly different. And this allows us a way to quantify that uncertainty. And so we can see, looking at these bars, that again, in the actual population, the range of plausible values is somewhere between 61 to about 67% for the yeses. And we can do something very similar for the no's and the unknowns. So this gives us a way, again, to kind of estimate what's happening in the population based off of the sample data that we collected. So for your assignment to go along with this video, I'm going to pull up the assignment here. You're going to repeat this process twice, once for each of the topic variables used in your report. And then you're going to create a write-up. So in the write-up, at the beginning of the document, you're going to write a paragraph describing what a confidence interval is and why it's useful for the reader of your EPI report. So similar to what I just discussed in the video. You could also have a look at the Place Matters example EPI report that we've seen previously. And as a reminder, you can find this all the way back in Module 1. It's also located in some of the other modules. So if you have a look at page 6, in the Understanding the Data section, this report does a really nice job of describing what a confidence interval can tell us, and they even use the BRFSS as well. So this is a great resource. I definitely recommend to read through this to see what this would look like in practice, how you could describe this to a reader. And if you scroll down, you'll notice that they do something very similar. They also put those error bars over top of their bar plots to help the reader understand that the bar plot's really showing what's happening in the sample, but these confidence intervals can give us an idea of what's happening in the population. So if we go back to the R code, let's just talk through one more time what it is you'll need to change for your code for each of your variables. So starting at the top, again, you'll want to read in your data set. For each of your variables, you'll repeat these pieces of code. You'll first start by creating a new variable that contains the appropriate labels. Then you're going to create your frequency table with the confidence intervals in the table. And so changes we'll need to make here. You'll want to put in the name of your data set. You'll want to call in that new variable that you made up here. Again, you'll give the new variable name. And then you won't need to make any other changes to this piece of code. You'll do this for your first variable. Then when you go to do your second variable, you'll do the exact same thing, except instead of table 1, I would call it table 2 in that case. Next, down to make your plot, the changes that you'll need to make, you'll want to call table 1 if you're working with your first variable, or table 2 once you've created that for your second variable. The name of the new variable you created with labels. You can change the color here to change the color of your plot. Now one thing, eventually you will be placing these plots into your EPI report. So in the second draft, one of the sections you looked at whether or not for each of your topic variables you either had 2 plots or 2 tables. These plots will eventually go into that section. So I would look at the color scheme that you're using in your EPI report and to use that. You won't need to change anything on the second line. But down here, you'll want to give it a meaningful label for the title, the y-axis, and the x-axis. And then just as a reminder, remember that the n equals here, that's the total number of observations that are used to make your plot. So one way that we can find this is looking at your frequency table. If you sum up all of the values or all of the frequencies here, you'll get the total number of observations that were used to create that plot. And so that's what value you will want there. So once you create your tables and your plots, if we go back to the assignment, you're going to create a write-up. So again, at the beginning of the write-up, like I was saying earlier, this will be similar to what I talked about in the video as well as in that EPI report. You'll insert both the table and the plot from step 2 for both of the variables. And then after each table and plot combination, you'll include an interpretation of the confidence intervals within those tables and plots. So for example, if I were working with the pneumonia vaccine, I would include this table, of course formatted in Word. I would then include this plot, and then I would include an interpretation for the 3 confidence intervals contained within this plot. Just as a reminder, when you're including plots either in your write-up or in your report, I highly recommend to click on Export and Save as Image to get those images out of R instead of taking a screenshot or other way that you might do that. And then also don't forget, you can always stretch the plot either way if you're having any trouble with your labels not being visible. And then again, you can export and save the image. All right, so that is going to conclude this video. As always, if you have any questions or you need any help, please reach out and let me know. I'm more than happy to help in any way that I can.